Okay, this last video in this section, section 7.1 through 7.3, 7.7, video part 2. I left off at the end of my last video, and I put up these two problems right here. And I told you that it turns out we can reduce this one, but we cannot reduce that one. Now, neither one of them are whole numbers. I can't get the square root of 20. It's not a whole number. I can't get the square root of 30. It's not a whole number. But we can reduce square root of 20, but we cannot reduce square root of 30. So I need to do two things. First of all, I need to show you how do we know it can be reduced. What makes this one reducible and not this one? And then the second thing I need to do is show you how do you reduce it for these problems. Okay, let me take this note down. Pause the video as you need to. Take this note down. A square root can be reduced if its radicand is divisible by a perfect square other than 1. Okay, I'm assuming you had to pause and start that video, but let me say it again. I said a square root is reducible if its radicand, remember that means this number, if it is divisible by a perfect square other than 1. Now, before I'm ready to talk about that note, let me talk again. You've heard me do this before. What is a perfect square? A perfect square is any number that you can factor as something times itself. So let me just write out a string of them. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are perfect squares. Now, it's easy to list the perfect squares because this is 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. So these are the perfect squares in order. So there's no perfect squares between 1 and 4. There's no perfect squares between 4 and 9, and so on. Now, in what I'm about to show you, we don't ever use the number 1. All right, now let me go back to the note that I said. You can reduce a square root if its radicand is divisible by one of these numbers right here. But it has to be one of the perfect squares. Well, I'm going to ask you now, is there a number in this list that will divide evenly into 20? Yes, 4 will. Is there a number in this list that will divide evenly into 30? No. Now, there's a bunch of numbers that divide into 30, but there's no perfect square that divides into 30. That's why this one is reducible and this one is not. So if you can find a number, a perfect square, that divides into that radicand, you can reduce it. So that's how you can tell. Now what I want to do is show you how you reduce it. All right, so let's look at some examples. So let's reduce square root of 20. All right, we just said this, but I'll ask it again. What number in this list that's a perfect square, what perfect square divides evenly into 20? 4 will. So here's what I'm going to do. Rewrite 20 as 4 times, and it divides evenly, 5. Now, remember we said a while ago, if you're multiplying under a square root, you can break it apart as long as they're not both negative. So, I'll break this into 2 parts. Now, one of these is doable, one is not. What is the square root of 4? It's 2. I cannot get the square root of 5. That is not doable. So you must leave it under the square root. So square root of 20 can be rewritten as 2 square root of 5. Now, I'll say this every time I do one of these. A lot of calculators, particularly this one right here, it's got the aqua color face. If you get in the right mode, will reduce this for you. I have no issue with that if you want to do that. I can't tell you how to get in that mode because every calculator is different. But if you want to use your calculator to do this, that's fine. But it's not difficult to do. So I want to show you without the calculator on the ones I'm going to show you. So square root of 20 is 2 times the square root of 5. Or we just say 2 square root of 5. Now, back to what we said a while ago. Square root of 30. Is there a number here that divides evenly into 30? No, not a perfect square. So this one is reduced. But if there was a negative under here, you could still put an I in your answer. But you can't reduce the square root of 30. Alright, so let's do 4 or 5 more of these and that'll close out this section. So let's do square root of 45. First, can you get the square root of 45? Is it perfect? No. Then the next thing you ask yourself, is there a perfect square that divides? And remember, if it helps you to write down the perfect squares, do so. But yes, there is a perfect square that divides into 45, and that's 9. Now break this into 2 parts. And one part is doable. I always put that part first. And the part that's not doable, put back under the radical. Now, what would I do if there was a negative under here? Negative there. I'd put a negative here and a negative there, and there'd be a negative in my answer. Okay, let's do another one. Three square root of 75. Can I get the square root of 75? No, I cannot. But can I reduce it? Well, I can reduce it if there is a perfect square that goes into 75. There is a perfect square that goes into 75. 25. Now notice I left that 3 out front, and that's understood 3 times square root of 75. Now I can take this, break this into 2 radicals. One part is doable. Square root of 25 is 5, and that's multiply. I'm going to put a dot there so that it doesn't look like 35. And the part that is not doable, leave alone. So this would be 15 square root of 3. Okay? Now, let's look at square root of 72. And again, remember, if you get in the right mode with your calculator will do these for you. All right, square root of 72. Now, square root of 72 is kind of a neat one to do, and the reason is this. There are multiple perfect squares that divides into 72. Let me show you the perfect squares that divides into 72. 4 divides into 72. 9 divides into 72, and 36 divides into 72. All 3 of these divides into 72. You don't believe that? Take your calculator and divide it. So you say, well, which one do I use? Well, it's kind of like we're simplifying a fraction. If you're simplifying a fraction like 24 over 32, 24 over 32, 2 goes into both of those, 4 goes into both of those, and 8 goes into both of those. Now, what's the problem with using 2? If you use 2, you end up having to reduce it multiple times. Same thing here. If you have more than one perfect square that divides into 72, if you use the bigger of the ones, you only have to reduce it once. So what I would suggest is either use your calculator or use the biggest of the perfect squares. Then break it into two parts. And then this would be 6 square root of 2. Now, let me come back and insert something else again. If there's a negative under here, what's that going to mean you're going to have in your answer? You're going to have an I in your answer. If there's a negative under here, we usually put the I in front of the radical. What if there's a negative in front of it? You'd have a negative in front of your answer. Now, let me just go back and show you something else. Just to show you that you get the same answer. Suppose you did 9 first. 9 times 8 instead of 36. Now, let me break this into two parts. This one is doable. Square root of 9 is 3. Square root of 8. But if you will stop and think, square root of 8 is reducible again because there's another perfect square that goes into 8, and that's 4. So what I have to do to completely reduce this is break up 8 is 4 times 2. Break this into two parts. One part is doable. And then you get 6 square root of 2, which is exactly what we got in the previous example. It just, I had to reduce it twice. So if there's more than one perfect square that goes into your number, use the biggest of them to get to your answer quicker. Now, I've done this already, but let me just do another one for you right here. So if I have a negative under here, that immediately means I'm going to have an I in my answer. Now, forget the negative. All right, 18. Can you get to square root of 18? No. Is there a number that goes into 18 you can get the square root of? Yes, 9. 9 is a perfect square. Now break it into two parts and do the part that is doable. So that would be 3 square root of 2i. Now, we commonly write it this way. The reason we usually do this is because a lot of times if you're not careful, you will accidentally put this I up under that radical. And it doesn't go under that radical. So, anyway. All right. One more. First of all, what does this negative do? That negative means it's going to stay out. Next, what does that negative do? It means you're going to have an I in your answer. Now, let's reduce square root of 30. Is there a number that goes into 30 that you can get the square root of? That's the key. It's got to be a perfect square. No, there's not. So there's nothing you can do with that. So that is the answer to that problem. Now again, we typically put the I in front of the radical to avoid the mistake of putting it underneath there. But that's the answer there. Okay, so this completes the 7.1, 7.3, 7.4 video, whatever it was, 7.7. 7.1, 7.3, 7.7 section of homework, part 2. And so the next section to come will be section 7.3 video, part 1, the distance and midpoint formula. And there will probably be only one video to it.